Hey everybody, thank you for joining me, Mrs. Woolley. Today is October 1st. Happy October 1st. And we are looking at our second day of estimating square roots. For our agenda, we're going to complete our do now, and then we're going to look at estimating problems. There are 9 of them, and then you can start your homework. It is in this Google Slides presentation. It is on slides 7 and 8, and it's nice review problems. So the first thing we're going to do is complete the must-do problems. And so we're going to use the order of operations to complete the do now problems. And if you remember, the order of operation is PEMDAS, and there are 4 steps: parentheses, exponents, multiplication and division, and then addition and subtraction, and we complete these left to right. So the first thing I'm going to do is simplify the parentheses. So I need to rewrite the rest of the problem. And I know the difference of 17 and 4 is 13. Now I'm going to check to see if there are any exponents, and there aren't. So the next thing I'm going to do is my multiplication, and it's right here. And I know the product of 2 and 13 is 26. And then the last thing I'm going to do is my addition, which is right here. And I know the sum of 3 and 26 is 29. Okay, on problem number 2, we are given an absolute value symbol. So if you remember, the absolute value is the distance the number is from 0 on the number line. It is never a negative amount. It can be positive or 0. So we treat absolute value like a grouping symbol, which means we do the math inside first. So I'm going to rewrite negative 9 minus 6 as negative 9 plus negative 6. And I need to keep those absolute value symbols there. Now I know that negative 9 plus negative 6 is negative 15. And then finally, I'm going to take the absolute value of negative 15, which is 15. And I'm going to circle my answer. You'll notice there is no absolute value symbols in my final answer because I evaluated the expression taking the absolute value as 15. So the next thing we're going to do is go on to estimate irrational numbers on a number line using our knowledge of perfect squares. So you are given 4 different irrational numbers: the square root of 14, the square root of 20, the square root of 61, and the square root of 47. You can physically move these on your Google Slides. I unfortunately cannot. So I'm going to just place the actual numbers above the different points on the number line. And I'm going to use again my knowledge of perfect squares. So if I think about the square root of 14, I know that sits between this perfect squares 9 and 16. So when I take the square root of that, I know that the square root of 14 is between 3 and 4, and I can physically see it's closer to 4. So if I look on the number line, I would put the square root of 14 at point B. The next square root is 20, and I know the square root of 20 sits between the square root of 16 and the square root of 25. And it's actually just about in the middle there. A little bit less, so I'm going to go with point C and put the square root of 20 at point C. The next one I'm going to look at is the square root of 47, and I know that sits between the square root of 36, which is 6, and the square root of 49, which is 7. And I know that 47 is closer to 49, so I know the square root of 47 would be closer to the square root of 49, which is 7. So that would put this at point E. And then the last example is the square root of 61, which sits between the square root of 49, which is 7, and the square root of 64, which is 8. And I can see it's much, much closer to the square root of 64 because 61 is closer to 64. So I'll put that at point F. So we place these square roots on the correct points on the number line. So the next thing we're going to do is estimate the square root of 61 to the nearest tenth. So again, we're going to be using our knowledge of perfect squares. And so I first have to ask myself, which two perfect squares is 61 between? And we sort of reviewed these already up above. I know it's between 49 and 64. I also know that when I take the square root of 61 is going to be larger than the square root of 49, which happens to be 7. And it's going to be smaller than the square root of 64, which happens to be 8. So if I was to look at this number line, the square root of 49 is right here, it's 7. The square root of 64 is right here, and it's 8. And I can physically see the square root of 61 is right here. So if I was to look at how close the square root of 61 is to these whole numbers, I can see that it's much closer to 8 than it is to 7. And so I like to kind of look at the distance. It's only 3 units away. If 61 is 3 units away from 64 versus being 12 units away from 49. So it's much, much closer. Or I could say it's about 12/15 of the way on the number line, which gives me about 3/4 of the way on the number line. So I'm going to say it's about 7.8. And then I'm going to have you check that by multiplying 7.8 times 7.8 on paper. And you should get an answer of 60 and 84/100ths, which is pretty darn close to 61. So this is a good estimate. If my estimate was off, I'd base that first multiplication to decide, do I have to go up or down on my guess. Okay, so now we're going to look at some previous MCAS problems. And the first one is problem number 1. It says, which number line shows the plotted value to the nearest tenth of the square root of 11? So I know square root of 11 sits between square root 9 and square root 16. And it's closer to the square root of 9. So I know that square root of 11 is going to be closer to the number 3. And so when I look at those number lines, I know that it's going to be about B, about 3.3. So if I was going to multiply that out, I come up with 10.9, which is pretty close. So B is a good estimate. And so the next problem asks which point on the number line best represents the square root of 10. Well, the square root of 10 is going to be a little bit less than the square root of 11. It's very, very close to the square root of 9. So I would say point B. And on your work, you can just drag this red oval circle to the multiple choice answer that you want to choose. So for problem 10, it says points K, L, M, and N are shown in the number line below. Which points on the number line best approximates the square 2 times the square root of 3? Well, if I just wanted to approximate 2 and instead of using the square root of 3, I use the square root of 4. I know that 2 times the square root of 4 is the same as 2 times 2, which is 4. So I know it has to be less than 4. So really, the only option here is m. But the square root of 3, if I wanted to be a little bit, more precise, I could say, well, what do I think the square root of 3 is? Well, it sits between the perfect square of 1 and the perfect square of 4. So I'd say it's pretty close to 4, the number 3, so the square root will be pretty close to 2. So I could use an estimate of like 1.7 or 1.8. Either way, it's going to bring me over here to this point m. Okay, that is number 6. Now we're going to go on to number 7. Number 7 asks for the value of the expression 8 minus 3 square root 16. So again, we're following PEMDAS. There are no parentheses. We treat a square root like an exponent because they are inverse operations. So the first thing I'm going to do is take the square root of 16, which is 4. So now I have 3 times 4. And so now I'm going to do my multiplication. And 3 times 4 is 12. And 8 minus 12. Now I'll do my subtraction. And the answer is negative 4. Okay, the last problem, Miranda bought a square frame that has an area of 30 square inches. What's the approximate side length of the frame? So remember, when you're talking about the area of a square, it's side squared. So we're going to take the square root of 30. So when we take the square root of 30, we have the side. And if I think about the square root of 30, it sits between the square root of 25 and the square root of 36. So it sits between 5 and 6. And 30 is just about halfway between 25 and 36. So a good estimate would be 5.5 or 5.6. So my suggestion is we go with 5.5. And I'm going to have you multiply that out to see how close it is to 30. And I got 30.25, so that's a great estimate. Now, what are my units? Well, if the area was square inches, this is going to be inches. All right, so I hope you found this video helpful, and I hope you're starting to feel more comfortable with the idea of estimating square roots. Thank you for joining me.